Now let's go ahead and look at addition rules of mutually exclusive events. Again, keep in mind, what are mutually exclusive events? Mutually exclusive events are something that cannot happen at the same time, something that don't share, something that they don't have anything in common. They're disjoint. They're like siblings. They don't want to share anything. Okay? So the addition rule says the probability of A or B when A and B are mutually exclusive, that is, when A and B don't share anything in common, then the probability is simply probability of A plus probability of B. Can you guess what is missing? Minus probability of A and B. This is missing because this cannot happen. They don't have anything in common. Or so remember what and stands for. And is something in common. They don't have anything in common. They're like siblings. They're always fighting. So when probability of A or B, where A and B are mutually exclusive, it's simply probability of A plus probability of B. All right. Now, having known that, let's go ahead and look into the examples. All right, let's go ahead and take a look at this problem here. If a police officer pulls over someone for speeding, okay, the police officer can either give a ticket or warning. So it's impossible for the police officer to give you a ticket and a warning for speeding. I mean, it can. He might give you a ticket and say, I'm warning you, but mathematically, both of them cannot happen. If the probability that the police officer will give a warning for speeding is 0.3, so I'm going to go ahead and write down. I'm going to say warning is W and ticket is T. So as of now, I know that probability of warning is 0.3. Very good. Sorry, 0.03. Okay? And the probability that the police officer will give a ticket or a warning for speeding is 0.5. So the probability that the police officer will give a ticket or warning is 0.52. What is the probability that the police officer will give a ticket for speeding? So here they're telling me find the probability of T. Remember what the formula is? When they're mutually exclusive, remember they are mutually exclusive because it is impossible for both of them to happen together. So probability of T or probability of W is simply probability of T plus probability of W. Do I know what T or W is? Yes, 0.52. Do I know what probability of T is? Nah, I don't know that. Do I know what probability of giving a warning is? Yes, 0.03. Now all I have to do is subtract 0.03 from both sides. And what do I end up with? Positive 0.03, negative 0.03 cancel each other. And I have probability of T is equal to 0.49. So the probability that if you're speeding and you get pulled over, the probability of you getting a ticket is 49%. Well, getting a warning is more, but getting a ticket is 49%. All right, now let's go ahead and look at the next problem. During a workshop, a team building activity met at the same time as the problem solving activity. So it was impossible for an employee to do both. So what are they giving you a hint? They're saying, hey guys, it's impossible for both of them to happen together. They cannot happen together. Remember what the keywords are. The keywords are, cannot happen together. So nothing in common, no sharing, and cannot happen together. These are the keywords for mutually exclusive. Nothing in common, they are not sharing, and cannot happen together. All right? So here they're saying it's impossible for them to do it together. That means they are mutually exclusive. That's the hint they are giving you. If the probability that an employee did the team building, so he did the team building activity. So I'm just going to say team building activity. What was the next one? Problem solving. So I'm going to say team building is T. The team building, the probability of team building is 0.02. and the probability that the employee did the problem solving. So probability of problem solving is 0.39. What is the probability that an employee did either the team building or, remember the keyword or, problem solving? So probability of T or P is simply probability of T plus probability of P, which is 0.02 plus 0.39, which is again 0.41. All right, now let's look at one more interesting topic, which is independent events. So two events, A and B, are said to be independent. They are said to be independent if the probability of one does not affect the probability of other. Now you might say, what events are those? Remember the examples I gave you in the first session? You eating an ice cream and getting an A in the class? They have nothing to do with one another. They're independent. Raining and probability of raining and getting an A in the class, or probability of tossing a coin and eating steak. I don't know, I'm just coming up with example. They're totally different events and have nothing to do or have nothing in common. Now, but you might ask, what are something that might have in common? Let's say eating an ice cream and catching cold. They do have something in common, right? Raining and power cut. They do have something in common too. So events like this, where one might affect the other, they are not independent. But events that do not affect one another, they are independent. Okay? So now let's take a look at the examples. Trust me, it makes much more sense when we work on examples. All right. So for multiplication rule, so the multiplication rule, this is called the multiplication rule. Why? If events, where are my events? If events A and B are independent, then probability of A and B is simply probability of A times probability of B. Now let me give you a hint here. The keyword or is addition. The keyword and is multiplication. When they are independent. Okay? What do I mean when they're independent? Like one does not affect the other. So let me go ahead and show you different examples. This is a very good example. If you roll a fair dice, so you're rolling a dice and then flipping a coin. So you're rolling a dice. I got so pro at drawing these dice. So you are rolling a dice here and you flipping a coin. Okay, now let me ask you this. Are these mutually exclusive? So when I say mutually exclusive, I'm saying you cannot roll a dice and flip a coin at the same time. Is that true? No, you can do both. So they are not mutually exclusive. The next question is, are they independent? What does that mean? Like if I toss a coin, does that change how I roll a die? Is that possible? Let me show you an example. So here I have an example. I'm going to go ahead and roll a dice. There you go. Flip a coin. Roll the dice again. Flip a coin again. So as you can see, they're independent of one another. They have nothing to do with one another. They're totally independent. What comes or what the outcome on the dice has nothing to do with if you get a head or a tail. All right, let's go back to the problem. So if you roll a fair dice and then flip a coin, a fair coin, what is the probability that you roll greater than 1 and get a heads on the coin? So what is happening here is they're asking you probability of rolling greater than 1. So now let's go back and see how many sides does the dice have? 6, right? A fair die has 6 sides. So rolling, where is my pen? Oh yeah, it's right here. Rolling greater than 1 and getting a heads on a coin. And they're asking me for the word and, probability and. So probability of rolling greater than 1 and rolling a heads on a coin. When I know it's and I know they are independent, I know I have to multiply the probabilities. So I have to multiply probability of getting or rolling greater than a 1 times probability of getting a head on a coin. All right, let's start with the dice. How many sides do I have in the dice? 6. What's the probability of getting greater than 1? So I have 6 sides. I can get a 1, 2, 3, 4, 5, 6. But I want greater than 1. Greater than 1 is 2, 3, 4, 5, 6. Those are 5 options. Now probability of tossing a head on a coin. How many sides do I have on a coin? 2. How many heads? 1. So the probability is simply 5 over 12. Let's look at the next problem here. If A and B are independent, remember they're independent events. So as soon as I know they're independent events, as soon as I know they're independent events, I know that probability of A and B is simply probability of A times probability of B. All right? They did not tell me what the events are. They just told me they are independent. So probability of A and B is simply probability of A times probability of B. Okay, but what did they give me? They gave me probability of A, which is 0.90. What are they asking me to find? Probability of B. So I don't know what that is. What else did they give me? Probability of A and B, which is 0.54. To find probability of B, you simply divide both sides with 0.9 and you end up with probability of B is equal to 0.60. All right, a couple has 2 children. Let A be the event that the first child is a boy and it's denoted by P of A, having a boy, 51.2%. Let B be the event that the second child is a girl, denoted by probability of B, 48.8%. A and B are independent. They already told me they are independent, so that's good. I know that the probability of A and B is probability of A times probability of B. What is the probability that the couple has the first child, that is boy, and keyword is and stands for multiplication. The second child is a girl. So probability of the first child being a boy and probability of the, boy is A, right? Yeah, boy is A. Probability of the first child being a boy times probability of the second child being a girl. So probability of A is what? Here they did not give me fractions, they gave me percentages, so I can multiply in percentages. 51.2 times 48.8. That approximate to 25%. Let me cross check. Yes, the answer is approximately 25%. Hope this helps. Again, if you have any questions or comments, please don't hesitate to email me, and good luck.